Now we're going to look at using the standard deviation as a ruler. Now IQR is great to know the middle spread of the data, but what if you want to know if a point is more far away than you expect, or compared to another point, or what percentage of the data falls between 2 points? For normal distributions or nearly normal distributions, which we'll be studying, we can use a relative measure, which is the number of standard deviations away from the mean. So let's start by looking at this example. Adult male heights are on average 70 inches with a standard deviation of 4 inches. Adult women on average are a bit shorter and less variable in height with a mean height of 65 inches and a standard deviation of 3.5 inches. Laura is 72 inches tall and Mike is 77 inches tall. Who is taller compared to their averages or their groups? So first of all, let's just figure out how much taller than average is each person. If we go straight measurement, they're both the same. They're both 7 inches taller than average. Does that mean they're equally tall in their groups? Well, let's take a look at how many standard deviations above average is each person. Laura's z-score is 72 minus 65, or 3.5. So she's 72 inches tall. The average is 65, and the standard deviation is 3.5. So we find out that she is 2 standard deviations above average. Mike is 77 inches tall, and that's above the 70-inch average with a standard deviation of 4 inches. He's 1.75 standard deviations above average. So compared to within the group, Laura's actually taller than a larger percent of her group than Mike is. So Laura is taller compared to her group. So this brings up the z-score, which is a way we measure how many standard deviations a point is away from the mean. And on your formula chart, it looks like this. It's on the back. Z equals the statistic, or test statistic is statistic minus parameter divided by standard deviation for the statistic. A lot of times you'll just see it written as this. Z equals your x, which is your statistic, minus the average for your parameter divided by standard deviation. So we basically take the distance between the point and the mean and divide by the length of the standard deviation. If z is less than 0, the point is below the mean. If z is greater than 0, the point is above the mean. Let's revisit this cool app where we can see the actual data live and how the numbers change. So here we are with my points. And before, we looked at the difference between the point and the mean. So if the point was lower than the mean, the difference was negative. If the point was higher than the mean, the difference was positive. Now, to find the z-score, all you do is take this value, in this case negative 6.6, and divide it by the calculated standard deviation. So 4 goes into negative 6.6, negative 1.65 times, roughly. I'm sure it's rounded. And as I move it around, so if I take this point and I move it further below, what happens to the z-score? It goes down, right? As I move it up and it gets closer to the mean, the z-score is getting closer to 0, becoming closer to positive until I get to the other side. And you can see that the z-score is all the way to positive. So it's actually more than 1 standard deviation away. And I can get it less than 1 standard deviation away, and then back to the negative side. So just looking at these z-scores, you can tell I have a point at 2 points that are below the mean, and I have 3 points that are above the mean because they have positive standard deviation scores. Which one's the furthest away from the mean? Well, based on the z-score, it looks like point A is the furthest away from the mean, and then point E, which kind of makes sense based on the picture. So let's go ahead and do some examples. My mom's height she is 4'11". So what's the z-score for her height? And again, I'm going to refer back to the information on adult women. And doing her z-score, her height, 4'11", that's 59 inches, minus 65, which is the average, divided by 3.5, negative 6 divided by 3.5, or negative 1.71. So what does it mean when a z-score is negative? The value is below average. And don't forget, half of z-scores are negative because half are positive, half are negative. We divide them up equally. Let's take a look at another example. On average, Umiat, Alaska has an average September temperature of 32 degrees Fahrenheit with a standard deviation of 12.2 degrees Fahrenheit. So that's telling you they have a pretty good spread in temperature. Ohio, Hawaii, has an average September temperature of 77.2 degrees Fahrenheit with a standard deviation of only 1.5 degrees Fahrenheit. So the temperature doesn't change much there. Last Friday, Umiat had a temperature of 20 degrees Fahrenheit and Ohio had a temperature of 70. Which location was colder than average? So let's go ahead and calculate their z-scores. Umiat has a z-score of negative 0.98. How'd we get that? 20, which is the day we were looking at, minus the average, 32, divided by 12.2. Ohio, on the other hand, this is unusually cold. It's 70 minus 77.2 over 1.5, negative 7.2 over 1.5. That's almost 5 standard deviations below average, so this would be considered quite cold in Hawaii. So Ohio was colder than average.